Okay, good afternoon everyone. Is everyone awake? Sleepy? Okay, so please don't sleep. Huh? It can be boring, but it can be interesting if you'll focus. So hi, my name is Rajni Balyan. I'm working with Fujitsu. Today I'm going to talk about partitioning in Postgres 11. It's kind of mixed, not only dedicated to Postgres 11, but I have some mix of Postgres 10 and 11 and some comparison so that you can understand what is different in 11 from 10. So let's begin. This is me. I think my face doesn't look like that. So it's being taken like 6 months back. So some difference is there. But yeah, at the moment I'm working with Fujitsu as a database support manager. I started my career around 9 years ago as a database administrator, specifically in Oracle. When I got my opportunity to work first time with Postgres, to be very frank, I was not having any idea what is Postgres. And by then I was working for like 5 years in Oracle, but I was not having any idea of Postgres. So I started learning Postgres in 2013 in my first job. And I really find it similar to Oracle. It was pretty easy for me to get this new database because it was really a good database by then. So you can see it's actually improving day by day, year by year, release by release, and I'm just loving it. So I'm also there in the community. I was a speaker in 2017 and 18 in Melbourne, so which is under PostgreSQL Down Under conference. It's same like APAC. I think Sameer is also a member of it, and we do have many active members. Andrea from Second Quadrant is also part of the same community in Australia. I was a speaker in APAC last year, Singapore, and this year I am the committee president, so I am the president of PGCQL Down Under committee in Australia. These are my contact details if you like. So let's start. So what is partitioning? Is anyone here don't know what is partitioning? Okay, everyone knows what is partitioning, right? Okay, that's good. We do have some touches of this partitioning here and there yesterday in many talks. So Stephen mentioned about partitioning improvements in 11, and there were some other talks. So I will not waste much time what partitioning is, but you guys really know what partitioning is. Like, it's dividing your parent table into the smaller tables, or you can say partitions. And if you have the database with this kind, it's better to partition like that. Yeah, this is the simple word. In the simple word, I can say is partitioning is like partitioning, dividing your data into as per your requirement into more relevant ranges or list or as per your hash. So today we are going to discuss about the partitioning. We will touch what is partitioning, partitioning exceptions, when not to partition, when to partition, what was the limitation of partitioning in 10 version, what are the advantages and improvements in 11, and then we will touch some of the improvements in 11 with still some limitation, and then what are we expecting in 12. So what are we expecting in 12 is actually copy paste from Steven's presentation. So don't blame me for that. Huh? Okay, partitioning PostgreSQL. As we already know that initially it was inheritance based from prior to version 10, but from version 10 onwards it is declarative partitioning, which means that there is no need to maintain the triggers, and there is no need to write rules for your data to come and enter into the right partition. So it can be done from the parent level, and it's a declarative. It's very easy to use, and it's convenient. So in PG10, PG is Postgres, right? So in PG10, we were having a list partitioning and range partitioning. We have actually added hash partitioning in version 11. Yeah, so this is one of the change that one of the addition in new version. it's not new version, I should say, because as Stephen mentioned about the PG12 already, it's going to be in beta in April, right?
Yeah.
In April, April, May. So it's not new, but it's good to know if you want to use partitioning in 12, so you should know the, the differences in all the partitioning over the period of time in all the versions. So why use partitioning? So usually when you use partitions, your queries are more faster, so the speed, the flexibility, and these are cheaper. These are the three, I should say, three main reasons to partition your data or your table. So queries will access only the relevant partition. So your queries will not actually touch each and every partition in a table. It will just touch the partition where the data is. So in that way, it's faster. So reporting queries access most of all your data in the entire partition. So if you know that your data is partitioned properly, you will actually go and hit only one partition. So that's again it's fast. It's again set up on the database level, so it's transparent to your application. So your application needs to just fire a query, and the database will return the data according to the partition. So it's transparent to your application. You don't have to do anything at the application level. It's flexible, easy to maintain. You can attach, you can deattach the partitions, you can create the partitions. So it's very flexible. You can archive the partitions by deattaching them. You can archive the partitions, and in that way it's flexible to take the backups. If you want to take a backup of a partition which you are not using very frequently, you can take it separately. So that's what, it's flexible in that way. It's cheaper because there is no need to maintain the indexes on your partition, so it's cheaper when used properly. So yeah, you can use actually you can keep your one partition on fast SAN storage. You can keep another partition which you are not using on the slower one. So in that way, it's cheaper. You can actually switch your storage. But it is not one fit for everything. So you have to actually think before using partitioning whether it's a requirement for you and all. Divide and rule always not work in a positive direction. So you have to think whether when you are trying to divide, is it actually going to rule, or is it actually going to ruin your system performance? So when to partition? So we had some suggestions last day as well. When to partition? Definitely when your table size is very big. How big? We had the discussion yesterday, but PostgreSQL documentation says the rule of thumb is if your table size is growing more than the physical memory of server, it's when you need to decide to go for partitioning, right? So it's not one fit solution for each requirement. You really need to understand when to partition. Another thing is when you know your data archiving is a requirement. When you want to keep the data for like 20 years, but you are not accessing that data on the daily basis, that's when your archiving is important. So you can actually archive that historical data without even deleting it from your main table, right? So that's when your archiving is required. You can think of partitioning. So if you can see in the example, I have a sales table. I have 3 partitions based on the year 2018, 19, and 2020, and I no longer need 2017 data. I'm not reporting, I'm not accessing 2017 data, but I don't want to delete that data even, right? So I can actually make this as a archive one, put it on the table space which is on a slow storage, right? And rest everything you can keep it on the save on the table space which is on fast storage. So that way you can actually maintain your data and achieve the performance. This is again the same thing. If you need a better I/O, you can actually keep your partitions on the separate table space depending upon your business requirement, how frequent you want to access the data. There are some partitioning exceptions that you should also keep in mind while deciding when to partition or not. So if you have any of such requirement which is there in the exception, partitioning is not your choice, right? Like if you want to truncate, if you want to use a function, if you want to use truncate only on the partition table, you can't do that, because truncate only on the partition table is the parent table, right? And the partitions are the child. So on the partition table, you can't use truncate only, because the partition table is having childs underneath, right? So there is a dependency. So only to add or drop a constraint, you can't use only to drop or add any constraint on your partition table, because now it's a hierarchy. So you have to think about all these exceptions. Your columns should be same in partition table and partitions. So columns should be same. If there's a requirement to have a different columns on the child table, partitioning will not fulfill your requirement. So you have to be aware of all the exceptions before actually thinking of partitioning. Another thing is, before you actually think of a partitioning, you should also be aware that you should know on what partitioning key you are going to partition your data. So you can take advantage of partitioning if you are using your partition key in where clause. If you are not using your partition key in where clause, you are not going to get any benefit, right? So these are the few things that you should keep in mind before even deciding to go for partitioning. Let's see how it is. And these are very important things, right? That's why I have put them in my slide, because see, partitioning is very cool, we can do that, we can divide that, but at some point in time, you should not think, oh, I have done a very big mistake. It's a blunder. So you should have all these things. I believe before going for anything, rather than having positive offits, you should have negative offits first. What could be the side effects? What could be the impact of if I'll choose this? So if you have those exceptions, those constraints in mind, you can actually take a good decision how to partition your data. When not to partition. So this is again related to the same thing. When your table size is very small, you can't go for partitioning. Like we are having a talk yesterday, you can't go for partitioning for 1 gig of table, right? So you should know how your data is growing. If you can say, okay, today my data is 5 gig, but 2 years down the line it's going to be a 5 TB. You can plan in advance. So you should know the growth of your data. You should know what is your current requirement and what is your future need. So according to that, you have to take a decision. You are not facing any performance issue. Your queries are performing super fast, giving you results in milliseconds, right? You don't unnecessarily complicate the things by partitioning because it's cool. I can say, okay, my organization is using partitioning with 1,000 partitions in place. No, it's nothing to feel proud about. It's how well you actually think about using any functionality in any database, in any technology. So groundwork should always be there. Your application is mostly read-write intensive. So you are actually reading and writing the data everyday basis. So that's where you need to think. So if you want to have if there's a need to archive your data, keep it, like don't delete it from the system. You might need it maybe after 2 years. So that way you need to think that your application is write intensive, it's writing, then you can actually divide your data according to your requirement. So when archiving of your data is the requirement, you can actually think, is not the requirement, you can actually think of not to partitioning, not to use partitioning. So we know that we started partitioning from version 9.5, inheritance, 9.5.9.6, or from 9.6?
Talking about inheritance or declarative partitioning? Because declarative partitioning
is from 10.
10.
Yeah.
Inheritance has been around since like
9. Is it?
It's been around for a long time.
Yeah, so inheritance was there based on the rules, based on the triggers. You can actually do difficult to maintain, but from version 10 onwards, we have declarative partitioning, right? But there are still some limitations in version 10, which actually community looked seriously and improved in version 11. So let's see what are the limitations that we had in version 10. So in my example, I'm taking a sales table. You cannot actually create a primary key, foreign key, and indexes on a partition table. I'm talking about partition table, not about a table. There's a difference, right? You cannot, you can have partitions can have index, but your partition table, the index on the partition table, which is on the top level, cannot be created if you have partitions. And if you are creating, and that index on the partition table will not be applicable on partitions as well. So this is missing in version 10. You can't have primary key, foreign key, indexes on your partition table once your table is partitioned. You can have it on individual, on single table if it is not partitioned. That's not the point here. There is no concept of hash keys. You can't have hash partitioning in version 10. There is no concept of default partition, which we were discussing yesterday. So if you are trying to insert a data which is actually falling beyond the bounds that you have defined for the partition, in version 10 you will get an error. But in version 11, if you have defined a default partition, that data will go to the default partition. So it's missing in version 10. Again, there is no concept of partition pruning. So when you do a select on the partition table, it will actually scan through all the partitions, right, in version 10.
No.
Automatically, there is no partition pruning in version 10, right?
It's based on the inheritance plan, but it's there.
It's there. Yeah. So the point here is there is nothing like partition pruning enabled in 10, which is there in 11 by default.
Depends on your point of view. Constraint exclusion, I mean, that query would not scan the 2017 table in declarative partitioning under 10. I mean, that's
Okay.
the query. If you prepared it, then it might. Well, actually, it probably wouldn't because we use customized. But constraint exclusion is set to partition by default, and it does work under 10. It would exclude that.
Yeah, but not the way it's working in 11.
It's different in 11.
It's different in 11, so that's the whole point. So here what we are talking about the simplicity, you know. So it's different in 11. You can achieve everything here in version 10, one way or the other, right? But it depends how simple is it. It depends how are you going to achieve it. So this is the same thing that I have just mentioned in the diagram. So you will see many repetitions in my presentations because I always refer to the pictorial thing and then I have a text for your reference. So this is the same thing when there is no default partitioning, no support of hash partitioning in PG10. So based on this, let's see what are the improvements in version 11. So same table, you can actually create primary key, foreign key and indexes on the parent table. You can have child, you can have a different default partition, you can create a partition based on the hash key. You can actually update the data which can go from one partition to another, which was not possible in version 10. You can't do a update on a data which is in one partition. You will get an error. So this is possible now with version 11. And again, same thing with the partition pruning. You can actually, your planner will actually go and hit the right partition where the data is. So again, the same thing. So in general, now the partitions have the same capabilities like an ordinary table where you can create an index, where you can create a primary key, foreign key, and then you can do the update and insert and all sort of things. So now I am going through the all these things and all these improvements in detail. For the sake of simplicity, I have taken the example of range partitioning. So I am creating a table, parent table, and I am creating two partitions here, inserting something, and here now on you will see some differences in version 10 and 11. So you need to pay attention. So you can have, there is a concept of sub-partitioning as well. You can actually create a partition and then create a partition table, the child or the partitions, and then you can create a separate table and attach it as a child of your already partition table, right. So that's called sub-partitioning. So it's possible in Postgres in that way. So you can have an inheritance partitioning like this. You have one table, then you create separate table. This EMP1100 is a separate, entirely separate table, which is partition, and I have attached this table as a child to already partitioned table. So this is called your sub-partitioning. Yep. So if you can see in the example, in PG11, if you query your partition table, you can see that this EMP110 is further partitioned, right? But same thing is not here. So now the view is more friendly. So it's the same thing here as well. I have actually created this table as a sub-partition, but I cannot see in when I'm seeing when describing the table, I really can't figure out which table is for the partition. But in 11, you can actually see that table is for the partition. It's very minor, but it's very useful, friendly. It's the same thing if you in PG10 you can create an index on your partition table, but in 11 you can actually create an index. It will be applicable for your all current partitions and will be applicable for your future partitions as well. So whenever you are creating an index on a parent table, that index will be applicable for your partitions, your child as well. And when in future you will be creating new child, you will be adding say 2021 partition, right. So that index of the partition table will be applicable to that 2021 partition as well. So as you can see, in version 10 you can't create an index on your parent table. It will give you an error. But in 11 you can actually create an index on your parent table. So I think this is a concept of your global indexes and local indexes.
Right, that's not
yeah.
Just a little, yeah, they're all local.
Yeah.
They are getting recreated, they are created all.
Yeah. And this will be applicable for future partitions as well. Yeah. So we'll be attaching automatically to the future partitions the index on your parent. So if you are using index extensively, this is very good for your performance. Foreign keys, sorry. So foreign key support, now in PG11 you have a foreign key support. So you're actually what you can do, if you can see the example, I have created this table department, and now I am creating a table called department head and referring the department head as and giving reference to this table, and this is my partition table. But if you have a partition table and try to create a new table giving reference to it, is not possible. So you can create a partition table with the foreign key reference to another table, but you can't create a new table with the foreign key reference to the partition table. So the vice versa is not possible. Is it going to be?
Not yet, I think that's 20 to 12.
Better crop, huh? Okay, so it's not my fault. So default partition, this is very handy, yet come with some limitations as we were discussing yesterday, but still very handy. It won't actually just throw your data away, it will accept your data, irrespective whether you have created a particular partition for that data or not. So if you can see, I have created, and you can see the statement here. So you can create You can create your table, like I am creating EMP default partitions of table called EMP, and you don't have to define any limit here. If you can see, I am not defining any limit to create this default partition, I am just saying default, right. So, this is how you create a partition, and you are trying to insert a data into a table where there is no defined range. If you can see, that value won't fit in any partition, right. So, where that value will go, this value will go into the default partition actually, right. So, this is how it is, and when you query the partition table, you can see this is default. So, this is how you can identify this is my default partition. This is an example when you in 11, when you in 10, when you try to insert a data which is going beyond the bounds of your partition, it will actually give you. Okay, let's say something. Okay. No, so yeah, I'll take my words back. So, what I am trying to do here is, I have inserted a row into my default partition, and now I am going to create a partition which is actually having that value, which I have already inserted in my default partition. Then if you try to do that, you will actually get this error, violation error, right. So, the right way to move that inserted row from default partition to the proper partition is, you need to first detach your default partition from the partition table. You have to create a table, you have to basically create a partition which is having the bounds that you want to define for the value which you have entered in default partition. You have to move the data from default partition to this partition, and then you attach this partition to the partition table, and then you can reattach the default partition to the partition table. So, there are few steps that we need to actually follow when you are moving the data from default partition to the partition that you have created according to your requirements. And I am not sure we are going to solve this in version 12 or not.
So, I don't think there's any improvement in 12 to this specifically. I think that on the other hand though, I'm wondering, I mean, if you should have been able to just detach the default partition, add the constraints to the default partition, and then, and maybe rename it, and then move it into being your new partition without actually moving any of the data.
But you haven't defined any bounds to the default partition, right? Well, you have to define the bounds.
So you're presuming here already that everything, at least in this example, that everything in the default partition falls into the bounds that you have for PR1, right? Because you just do a insert into select star from.
Yeah.
So if you know that to be the case, then you should be able to detach the default partition,
rename it,
constraints to it, and reattach.
That's.
If you don't know, like if the default partition actually has other stuff in it, then it becomes a trade-off as to how you want to split that up. Either you move the other stuff out, or you move the stuff that you care about into
right?
So
here it's only one row, right? We know what the data is. So as you mentioned, if we having like 100 odd rows in this default partition, and we really don't want to move, or we can't rename that partition because that falls in the different bounds. So you have to actually come up with a strategy where you have to define the bounds, you move the data from default partition to the proper partitions. But still it's too.
It's hokey. I get it.
Yeah.
I mean, believe me, I agree. It would be nice to improve on that.
Yeah, but at least something is better than nothing. We have something. It's not throwing back your data. It's accepting your data at first place. And I think you can have some triggers or those sort of things to do this.
Triggers to help with some of the stuff.
Yeah, that manual thing is always there. But I believe personally, as a user, I think it should be improved in the further versions so that this can be simplified.
Yeah.
Yeah.
So if we add we have defined a partition, we should automatically move data from default to the new added partition.
Sorry, I didn't entirely follow that.
So my point is, we here you mentioned like detach the default, right?
Yep.
Detach the default partition, we added the new partition. Now we should not move data, but we should automatically move data when we attach the default partition back to the parent table. Because
It doesn't.
At the moment, it's not. Yeah.
At the moment, it doesn't.
It doesn't. It doesn't.
What it should do is a different question, but today it
Yeah.
does not do that.
Might be in future versions it should do that. Should be smart enough to.
I don't know if I would necessarily, I'm not 100% sure I agree that that would be the way to solve that, but maybe.
Smarter way.
I just don't like the attaching of a partition to end up taking a lot of time on it.
Yeah, just think about you have 1,000 odd rows in your default partition. It will be really a difficult task to move the rows to different partition. It's tedious task. Yeah.
For 1,000, I don't know if it would be an issue. For a few million, it would be a problem. But yeah, exactly.
Yeah. So this is again you can attach. So this is the whole process that we have discussed just now.
I think adding a partition concurrently when you have a default partition might be something where we would come up with a way to move that data from the default.
Directly, yeah. Once you attach the partition, which is actually falling into those.
Migrate the data.
Yeah.
And then have some kind of, this is something I was thinking about before, is have some kind of flag on the table that basically says all queries have to go scan the default partition because some data might be there.
Might be there, yeah.
As well as wherever it actually, wherever the constraint system does it.
Agree, yep.
Right, that would be a way.
That will be good. So it's same thing. So this is a new addition in version 11, which is hash partitioning. So what this hash partitioning actually does it, if you are not sure that how you are going to divide your data, you can still have partitioning in place using hash partitioning. So what hash partitioning does it actually separates your data randomly in a random way. So it has a partitions and more or the less partitions are having equal amount of data into the partitions. So this is fairly useful when you want to actually divide the data, but you don't know how to divide it. So you can make use of hash partitioning in those scenarios. So this hash partitioning is basically based on your modules and the remainders. So if you can see in this, I have a table and I have actually partitioned it based on the modules and the remainders. So the modules is actual number of partitions that you are going to do, and your remainders should not be less than your modules. So this is how you need to keep in mind when you are using hash partitioning. So yeah, this is the syntax to partition. So you it's same as range and list. You just need to say partition by hash, and then you need to you will be able to do the partitioning. You have to define your modules and the remainders. The key thing here to note is your module clause should always be greater than your remainder, as I mentioned, and your module is like your number of partitions that you are going to do. If you have modules less than your remainder, when you will try to insert the data, you will actually get an error. So that thing you should keep in mind how many partitions actually you want and how you want to divide your data. So there are some advantages. The main advantage is when you really don't know how to divide your data, you can actually utilize hash partitioning. It's not skewing your data into the one partition, making your one partition bigger. It's actually kind of equally dividing your data into number of partitions available. At least this is what it says, right?
Well, it's more defining, like how when you define the hash.
Well, the hash function is already defined. I think
No. So it's basically like how your data is actually scattered around those hashes. So that will define your own.
Yeah.
you definitely have hotspots.
Yeah. So yeah, this is you can say some advantages over your range partitioning, but this has been added in version 11, which was not there in version 10 of Postgres. So row migration on upgrade, as I mentioned in my that visual, that when you try to migrate some data which is falling into one partition to the another partition, somehow your requirement changed and you want to update or move that row to the different partition, you were not able to do it in version 10, but now you can actually do that in version 11. You can move your data across the partitions. So if you can see in an example, I am actually updating this record where your joining date is this. So I am actually changing the employee ID. So in version 10, this will give me an error, but in version 11 actually I can update the record. So this is a improvement in version 11 as compared to version 10. Partition pruning, as we are discussing, so it's enabled by default in version 11. So what partition pruning does, it actually performs, it actually enables your planner to look for the particular partition which is as per your partition key. So this improves your performance. It will not go through each and every partition, it will just go through the exact partition. I should not say it's something new in 11, it's something simple in 11. And this is a parameter, sorry? So this is an example when I have enabled partition pruning in version 11. If you can see my key, I am looking for 2018 and it is actually going for some partitions, right. But if I disable this for the same thing, it is actually going for 2017 partition as well, 2016 partition as well. So this is I have done on version 11 when you enable and disable the partition pruning. So this is a difference, you can say. Okay, so this is what we have in, I think still there might be something I might be missing here, but these are the you can say the major changes or improvements in version 11 as compared to version 10 as far as partitioning is concerned. And for the sake of simplicity, I have just put some useful commands here. If you need to know how your rows are distributed across the partitions, you can actually use this query. If you know which partition contains the row, you don't know how you have partitioned, but you want to know in which partition your record is. You can actually use this query to go and see which partition your record is containing, and it might be useful when you want to update something, right. So you need to know where it is and where it is falling. So these are the few commands that you can use. These are the few, there can be many. So I have just listed down what I have came across while doing this, preparing for this presentation. So as we are discussing, there are still limitations in PG11, and I am not sure, I am not the right person to say whether going to be covered in version 12 or not, but yeah, there are few things we should be looking for, like foreign key thing. It should be vice versa as well, referring to your partition table and the table. Default partitioning, it's good to have, but need to dash. So we need to improve it in the future releases so that we can efficiently utilize the default partitions. What's next in PG12 is actually copy paste from Stephen's slide. I have added some, Okay, so like still more to be here in the future, it's my thing. So I have added this. So I think how many partition you should have is actually again something you should look into, whether having thousands of partition will improve your performance or will degrade your performance, right. So, what I can actually think of moving onwards, we should not have a, there is no limitation though, but we should have not a constant on number of partition compromising on the performance. So, what I personally want community to look into is, as we grow, we should not compromise with the performance. So, maybe thousands of partition with better performance is what we should look for. Insert performance should be improved. We yesterday saw we are expecting deattach and attach in version 11 concurrently. Multi-insert during the copy is also what Stephen mentioned. PG partition tree function is also what we are expecting in version 12 to be there, so that we can have a better view of our partition. Nevertheless, we have, so this is something which is better than the declarative, the inheritance partitioning that we were having in past. And as Postgres is growing, the features are getting mature, and I'm sure by version 13 and 14, partitioning will be matured in Postgres and should be utilized, efficiently and automatically. Many things should be there. I have just compiled, as we were discussing about PG Partment yesterday. So, I have something, you might need to correct me, Stephen. So, this is something I have actually Googled, yeah, and as per my experience as well, what is there in 9.6, 10, 11 and PG Partment. So, PG Partment is a good tool which most of the companies were using where the requirement was there for partitioning, but I think PG 11 is fitting into the gaps now as far as partitioning is concerned. So, I am hoping like in future version 12 and 13 will have everything tick 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 against, yeah. So, yeah, go and see what PG Partment does, what natively supported in Postgres, have some comparison, because definitely nothing is better than native support. It's in the engine. You don't have to hook in anything, you don't have to think about any further complexity of using any further tool, maintaining its version, all those things. If it's native, it's best. It's in the engine. So, go and have a look of what your partment gives you, what PG 11 is. If you have any questions, anything, you can always connect me. So, am I running out of time, or I think 5 more minutes? Yes.
Well, just to go back to the comparison of PG Partment.
Yep.
Just something to clarify, right? So, where you talk about PG Partment using triggers for insert routing, that's when PG Partment is used with a version of Postgres that didn't already do tuple routing. Like 9.6, right?
Yeah.
So when you use PG Partment with PG 10 or PG 11, it uses default partition, right?
Oh, okay. It doesn't use its own.
It's been updated to work with default or declarative partitioning in 10 and 11. So it doesn't use triggers when it doesn't need to.
Okay.
Right? That's only there for older versions before Postgres had that. So
That's why there is a star.
Yeah.
The little star there.
Yeah. It made it kind of look,
Yeah.
it would be a complicated chart to put together, I think.
Yeah. So, it's really, I felt it difficult to put it. That's why wherever I was like half confident, I put star and the tick. So, it's being done maybe in a different way, or maybe like updated in the new version that I haven't played around with. So, nothing is available as such on the internet anywhere where there is a version by version comparison, feature by feature comparison in 10 and 11 Partment. So, you might just need to update it as per your experience, what you have gone through, what you are using, what you will be using in the future. So that's the beauty of any tool around Postgres, that they do update it according to the server version, according to the server, the features and enhancements. So that's why the tools are up to date. But I'm personally a native kind of person who likes to have everything in, so I'm greedy, you can say. So.
I think the main thing is, if you're running PG11 or the main thing department gives you just automatic creation of objects.
Yeah, so you can have, I think you can have partitions on the fly using PGPartment, right?
Well, it'll create them automatically for you.
You can script it to create it automatically as per your defined thing, yeah. So that's the main advantage of PGPartment. Yeah. Any question? Anyone?